Wait, guys. Okay, each bulb is labeled like that, right? We can find the resistance of each bulb. Actually, I want to find resistance of each bulb. Sorry. Okay. When P equals to VI, okay, I also equals to V over R. So P equals to V square over R. Now correct. So R is equals to voltage at each bulb is 12 power 2 over power is 24 watts. So what will we get? We will get how many? 24 to how many? 48 guys. Is it 48? Dapat 12 times 12 over 24. 1 and 2, 6. 6 6 ohms, okay, 6, okay, 6 ohms. So what I'm trying to do here is that I'm trying to show you all that each of this bulb is only 6 ohms. 6 ohms, okay, done with that part. Okay, now we know that each of the bulb is on,
Teacher, why the voltage was square?
Because the formula was such P equals to VI. So I equals to V over R. Substitute here. You get P equals to V square over R because we were only given power of the bulb 24 watts, voltage across the bulb 12 volt. That's not only what we're given one. So use the formula, you find the resistance equals to V square over P. So V was 12 power 2 over P is 24. So we get 6 ohms. So each of the bulb is only 6 ohms. Got it, Satish?
Got it.
Okay, now the next thing to understand here is that I'm trying to show an example first, then we go back to the question. Okay, now first we try to solve the parallel first. Okay, now we know that each of the bulb is 6 ohms. 6 ohms. Okay, so power, if each of the bulb is 6 ohms, 1 over R equals to 1 over 6 plus 1 over 6 plus 1 over 6. 6 ohms, 6 ohms, and 6 ohms. So total will be 1 over R will be 3 over 6. So total resistance here is only 2 ohms. So this whole circuit will have only 2 ohms. So if the whole circuit is having 2 ohms, what is the main current value? This is the main current value. So to find the main current value, V equals to IR. Main source voltage 12 volt. This is the main source voltage 12 volt. Main source voltage 12 volt. Main current we do not know, or effective current. Total resistance is only 2. So main current is actually 6 ampere. 6 ampere, guys, 6 ampere. So the main current here is 6 ampere. The main current here is 6 ampere. 6 ampere split to equal 66666 ohms. Each one will be 2, 2, and 2 ampere. All right? Okay, why this is very important? See here now. Okay, if you all follow this part, see here carefully. Okay, what am I trying to do is that to understand brightness of a bulb, you must use the formula P equals to VI. This is at each bulb. At each bulb, right? So power, voltage at each bulb is 12. Voltage at each bulb is 12, 12 volt. Current at each bulb is 2 ampere. If you see the circuit, main current was 6 ampere, split 2, 2, and 2. So power at each bulb is 24 watts. So each bulb is lighted at a power of 24 watts. This is the label of the bulb. This is the label of the bulb. So for the bulb is so I can tell in parallel the bulb is at a brightness of 24 watts, And since the bulb was labeled 24, 12 volt and 24 watts is a label of the bulb, the bulb is at normal brightness. The bulb is at normal brightness. Okay, keep this aside. Now we go for the series. Anyone got question with the parallel? Anyone got question with the parallel? This is the parallel arrangement. In the parallel arrangement, we try to identify, we try to get the amount of power at each bulb. So first we try to find out the total resistance in the circuit. Each one was 666. We found total resistance is only 2 ohms. With that knowledge, we try to find out what is the main current flows. We use the formula V equals to IR. We found the main current was 6 ampere. Since it's parallel and everyone is 6666 ohm, equal resistance, each circuit will get 2 ampere. Okay, we understand this part already. Now we go to the series. Okay, in a series circuit, all right, the voltage must be still the same, 12 volt. Now we have 3 bulbs, all are arranged in series. Okay, earlier we calculated if the bulb was labeled 24 watts and 12 volt, we calculated that resistance at each bulb is 6 ohms. So now when I see here, this circuit, each one is 6 ohms. So how to find the main effective current? This is the main effective current. This is the main effective current, the main current, the effective current. So how to find this value? V is equals to IR. The source voltage is 12. I do not know the main current. Total resistance now is 18 ohms. So the current will be 12 divided by 18, 2/3 ampere only. 2/3 ampere only. The next thing to understand, if the source voltage is 12 volt and each of the bulb are 6 ohms, each of the bulb will get a 4 volt voltage only. 4 volt voltage only. 4 plus 4 plus 4, we get 12 back. So power at each bulb. So what is the power at each bulb? Let's calculate. P equals to VI. Voltage at each bulb is only 4 volt and the current is only 2/3 ampere. So each bulb are getting 8/3. 8/3 is 2.66. Correct? 2.66 watts only. Any question? So when we calculate, thank you, when we calculate the power across each bulb, each of these bulbs are actually emitting a power of only 2.667 watts. So you can see or not? So comparatively, the parallel was brighter compared to the series. The parallel was brighter because the parallel was emitting a powerful, how many watts just now parallel was emitting? 24 watts, right? Just now, yes or not? Parallel was emitting 24 watts of power, but the series are only able to emit 2.667 only. So if you understand this comparison, okay, let's go back here. The question, so they're asking us based on 2 circuits, circuit 1 and circuit 2. One was in series, the other one was in parallel. Okay. Circuit 1 parallel, circuit 2 series. So compare these two and compare the brightness. Relate the brightness to deduce a concept in physics with regard to the potential difference, current flow in series and in parallel. So if I divide it in parallel, in series, okay, in parallel, I will tell each bulb receives the same voltage. Each bulb receives the same voltage. In parallel, effective or total resistance reduced. Effective or total resistance reduced, decreases. And in parallel, the main current or the effective current increases. In parallel, same potential difference across each bulb. Effective resistance decreases and the main current value increases. This is in parallel. The next thing to understand about parallel, okay, in parallel, if you understand the next thing, in parallel, each bulb produce a bigger power. Why? Because they have a higher current and higher voltage across the bulb. Each bulb produce a bigger power because they have higher voltage and higher current across each bulb. So comparatively, the parallel was brighter. The parallel arrangement were brighter. Now we go for series. In series, right, effective resistance was higher. Right, voltage across each bulb were divided. Voltage across each bulb were divided, so voltage were lower. Effective current across each bulb was lower. So in series, total resistance increases, voltage across each bulb decreases, current also decreases. When current also decreases, power emitted by each bulb decreases. Power emitted by each bulb decreases. So I can tell now comparatively, can tell now that the bulbs in series are dimmer to parallel. The bulbs in series are dimmer to parallel. Any question, guys?
No.
No.
Very good. Thank you very much. Okay, next. If you can do this, very good. Okay, now look at number 2. During a festival, a string of decorative colored bulbs were fixed in the veranda of a house. One of these bulbs got overheated and fused, gone, boom. This caused all the other colored bulbs to go off. However, the light in the house did not went off. So only the veranda, the colored bulbs all went off. Okay. Colored bulbs went off in the veranda, but the bulbs in the house did not go off. Okay. How were the colored bulbs connected? How, Marcus? Marcus boy?
Yes.
How was the bulb outside of the house were connected? Because one goes off, the whole thing went off.
They were connected in a series circuit.
Very good. This was in series.
Mm-hmm.
Next, Marcus. How were the light in the house connected?
Parallel.
Parallel. That's why it's not going off. Very good.
Mm-hmm.
What can you say about the relationship among the currents in the decorative bulb? Decorative bulb all were connected in series. So in series, what is the relationship of current?
I
Same,
don't know. Same.
Same amount of current flows to each of the bulb. Same amount of current flows to each of the bulb. Same amount of current flows to each of the bulb. Okay, clear?
Clear.
Okay, next. Thank you. Next one. Okay. The power supply to the house was 240 volts. 10 decorative bulbs were where each of the bulb was rated 24 volt. The decorative bulbs were arranged in series. So each bulb 240 divided by 10, each bulb is getting the 24 volt, right? And the bulb is labeled 24 volt. So if a bulb is labeled 24 volt and you supply 24 volt, the bulb will be at normal brightness. When your bulb is labeled 24 volt and you give in a voltage of 24 volt, the bulb will be emitted at what we call as normal brightness. The bulb will be emitted at what we call as normal brightness. Okay. Any question?
No.
Next. Very good. Each of the light in the house were rated 240 volt. But in the house, inside house, each were rated 240 volt. Based on the given information, deduce a physical concept relating current and voltage to series and parallel combination. Okay, write down first. Current. Okay, write down in parallel, in series first, in series. Circuit. In series circuit, the same amount of current, flows to all the bulbs. In series, the same amount of current flows to all the bulbs. In parallel circuit, the amount of current is divided to each branch. Okay, now done with current. Now we go for voltage. Okay, now we go for voltage. Okay. In series circuit, the voltage is divided to each of the component or electrical appliances or bulb according to the resistance value or the need value. In series circuit, the voltage is divided to each of the bulb or to each of the electrical appliances according to the need or according to the resistance value. Next, in parallel circuit, the voltage, the same amount of voltage flows to each branch of the circuit. The same amount of voltage flows to each branch of the circuit. Okay, any question? Any question?
No.
Thank you. Okay, so based on the given information, we are supposed to, right, deduce a physical concept relating current and voltage. Okay, done already. Okay, B done. Okay, next we go for C. In a household wiring system, what is the need of, my typing error in a household wiring system, why there is a need of separate fuse? Why there is a need of, not what, why? Why there is a need of separate fuse to electrical appliances? Explain why. Okay, when we having household electrical system, why we need a separate fuse? Okay, let's see. We know that our housing system, this is our housing system, this is AC, we receive AC current, then everything is branched out. This might be a branch for maybe one part of the house. Electrical appliances A, electrical appliances B, then they goes back. Then another branch. So many branches they'll have, you know. So each one is actually all of it are parallel, right? And there might be another branch here. So many branches we are having. Okay, now at each component here, we can actually place a fuse here. We can place a separate fuse here at each component, and they can be handled by separate switch also. Each one will have separate fuse and separate switch. Why is it so? Why? Because, so the question asking you, in a household wiring system, why there is a need of a separate fuse to electrical appliances? Okay, write down there. A fuse. What is the job of a fuse first of all? This is how we draw a fuse. This is the symbol of a fuse. Okay. Why do we need a fuse? Let's take a fuse attached to your TV. All right. When the main power supply goes from the 2-pin plug to your TV, at the back there, there'll be a fuse at the back there. Okay. You can't see it's at the back there, then goes to your TV. It's at the back of your TV. Let's say this fuse is labeled, okay, labeled 3 ampere. 3 ampere. So your TV only require 3 ampere. It will allow the current to flow sometimes up to 4.5 ampere. 4 all very common. 4, 4.5, 4 can. Above that value, if you see in the actual physical structure of a fuse, there will be a tiny metal wire in between. This metal wire can support current to a certain value. Let's say the 3 ampere fuse can support current up to 4.4, 4.5 ampere only. The moment the current shoot off more than 4.5, more than that, this wire will melt. The moment the wire melt, it will disconnect the whole circuit. It will disconnect the whole circuit. So that's the job of the fuse. A fuse will have a label value and it can support current to a certain value only. The moment the current flows more than the value of the fuse, a tiny wire inside there will be melting and disconnecting the whole circuit. So once you disconnect the whole circuit, what happened? The device connected is protected. The device connected is protected. Let's say, for example, this is your TV, right? And your TV only needs 3 ampere, right? So your TV only needs 3 ampere, and this is the 3 amperes fuse there. Suddenly a higher current flows, because in parallel, you must understand overloading of current can occur. Suddenly higher current flows. And let's say a 5 ampere current flows. Your TV cannot support that. So before the 5 ampere current flows, the fuse will be disconnected. The moment the fuse is disconnected, this whole part is disconnected, your TV is basically saved. So a fuse is a device. It is a device that can protect your electrical appliances. So in this idea, based on this idea, in a household wiring system, why there's a need of a fuse, a separate fuse, you write down there now. In case of a higher current flow, in case of a higher current flow, the fuse will disconnect. The fuse will disconnect the current. In case of a higher current flow, right, the fuse will disconnect the current to protect the electrical appliances separately. That's the most keyword, separately. It can connect it, it can protect it separately. This is the best part of it. Huh? Okay, any question?
Nope.
Thank you very much. Okay, next. Ammeters and voltmeters are used to measure current and voltage respectively. Okay. In a circuit, based on the way the ammeter and voltmeter are connected in the circuit shown, the circuit is not there, I'll show you now. Discuss the features of an ammeter and a voltmeter that make them suitable for each use. In your discussion, include the following. Are they connected in series or parallel, and why are they connected? Such as, how will the ammeter affect the circuit if it's connected? And what characteristic must the ammeter have? And what will the voltmeter, how will the voltmeter affect the circuit? Okay, now, see ya guys. Okay, first we go for basic circuit. This is the electrical circuit. Okay. Okay, I have one electrical device here, right? And then I have one ammeter here. Okay. Then I have one voltmeter here. Okay, now, when I see the ammeter is connected in series. Okay. Now the question, why ammeter is connected in series? The reason is to detect the rate of flow of charge, to detect the rate of flow of charge or the current to detect the rate of flow of charge or the current to the electrical appliance as the same value as the electrical appliance, as the same value as the electrical appliances. So why ammeter? Why ammeter is connected in series? Oh, to detect the value as the current as the same to the electrical appliances. So I want to know what is the amount of current flows, the same value as the appliance, because we know in series same current flows. That's the reason. Okay, done. Any question? Siapa ada soalan? I explained to you why ammeter must be connected in series. Any question?
No.
Tak ada.
Okay, thank you. Now we look at voltmeter. Okay, voltmeter here is to measure the potential difference across the electrical device. To measure the potential difference across the electrical device, we must know what is the amount of work done to transfer. The amount of work done to transfer one coulomb of charge from this point across the device to this point. So potential difference was the amount of work done to transfer one coulomb of charge across the device. So it must be connected in parallel, must be connected, the voltmeter must be connected in parallel to determine, the amount of work needed, the amount of work done to transfer, the amount of work needed, the amount of work done to transfer one coulomb of charge. through the device. To transfer one column of charge through the device. So it's best to fix it before and after device lah. So it goes through the device and come out only you know what is the voltage. So voltmeter is connected in parallel. So it will detect the value. Any question?
No.
Okay, done. Okay, next question. In the same question, they're asking us to explain. All right. Why are they connected in series? Why are they connected in parallel? So why ammeter is in parallel? Sorry, in series, I explained already. Why voltmeter in parallel? I explained already. Now, next thing, characteristics. You see, this is the source voltage. Huh? See here, guys. This is the source voltage. Okay. Let's say the source voltage is 3 volt. An ammeter is a device to measure current. So it should not use the voltage, all right? So all the 3 volts should be utilized by the device, all right? So characteristics of an ammeter that we use. Thank you, Marcus, because we are very close, Marcus, so we can hear. So characteristics, okay, characteristics of an ammeter is, see, ammeter must have very low resistance across it. Ammeter must have very low resistance across it. Therefore, ammeter will have or will use a very low voltage across it. And that amount is actually neglected. We do not count that amount. So if let's say ammeter pakai 0.2 voltage out of 3, it's not counted, not calculated. So characteristics of ammeter must have very low resistance to minimize as minimum as possible the voltage across it. So the voltage across a meter must be neglected. Do not count it. Okay. Who's suffering to get in?
Joshua.
Are you? Why?
He haven't come in, man.
Oh, yes.
So he got come in, but then he connection problem.
Oh, okay.
Teacher,
Teacher
can explain about the voltage again, because my connection also has some problem.
Oh, voltage very easy. You connect the voltmeter across it in parallel so that you know what is the amount of work done as the one column of charge move through it. So you will only know before and after. Before and after, what is the voltage? What is the voltage? What is the work done to transfer that one column of charge? That's how voltmeter is connected parallel. Voltmeter is connected parallel to identify the amount of work done to transfer one column of charge across any electrical appliances. So you fix the voltmeter before and after, you will get the actual value. What is the value? Okay, now we go for ammeter again. I just explained ammeter must be connected in series. Ammeter must have very low resistance so that ammeter do not use voltage. If can, a very high efficient ammeter will have the minimum voltage used, very low voltage. Okay, next ammeter done. We go for voltmeter. If you see voltmeter carefully, guys, it is connected in parallel to a device. Okay, let's see. This is your device, and this is the voltmeter. If you see the connection carefully, let's say a current of 2 ampere came here. All right. The whole idea here, the device, the electrical appliances, the bulb, the TV, the aircon, whatever is fixed there, this device should receive all the 2 ampere current. So voltmeter must have very high resistance, because when the resistance across a device is very high, minimum current will flow through it. So let's say 2 ampere current came, only 0.001 ampere enter to the voltmeter. This is neglected, we don't count. So every voltmeter must have maximum resistance across it so that minimum current can flow across it. Every resistor must have maximum resistance across it so that minimum current can flow through it. All right? Any question, guys? We'll be disconnected shortly. I can't continue today. Let me check tomorrow, then I'll update you all. All right? Later we can discuss also. So any question here?
Nope.
No.
All right. Thank you very much.
Thank you, teacher.